Hi, I'm Steve Sobek, owner of amysflashcards.com. This is the fifth video in a series of instructional videos on how to use the TI-84 calculator. The focus of this video is on solving systems of linear equations. 2-variable systems, 3-variable systems, 4-variable systems. It doesn't matter. Once we learn how to solve a system using the matrix method with the 2-variable system, you'll find that the transition to 3-variable systems with 3 equations is very easy. Now, the best timing for watching this video is after you've already solved systems of equations using the other methods. Okay, remember, to solve a system means to find the ordered pair, a value for x and a value for y, that make both equations true simultaneously. It's easy to find an ordered pair that makes one of these equations true, like a 0 for x and a 3 for y makes the first 0, 3 makes the first equation true, but it doesn't make the second equation true. Okay, there's millions of ordered pairs that make the first equation true, millions of ordered pairs that make the second equation true, but there's only one ordered pair that makes both of these equations true. And we have all these other methods. We hopefully have already used 4 other methods for solving these systems. We've used the substitution method, the linear combination method, which some books call the addition method, where we combine the equations, eliminating one of the variables. And we have the graphing method. Certainly we could isolate y and then go into y equal 2 and graph both of these functions on the same plane. Second, calculate intersect and find that point of intersection, which would be the solution to the system. And since these functions obviously have different slopes, they will have to intersect. There will be a solution to this system. Not all systems have solutions. The equations, the functions could be parallel to each other if they have the same slopes, and they would never intersect. Or they could have if they were 2 identical equations, they would coincide, and then every point on the line would be solutions. But we could see here we have different slopes. Certainly there will be one unique ordered pair that will make both of these true. Cramer's rule is maybe the 4th method that you've learned for solving systems of equations. The reason I like to cover this method after you've already covered the other 4, not because you need those other 4 to use this method, but because once I teach students this method, they don't want to use any of the other 4 methods. All right, so we cover those other methods first. Now, of course, with a scrubbed 2-variable system like this, it doesn't really matter. I mean, it's very easy to solve with any of those first 4 methods, and you hardly need a 5th method for attacking this. But when you get to 3 equations with 3 variables, or 4 equations with 4 variables, it becomes very tedious and time-consuming to use some of these other algebraic techniques. But with the matrix method, I could tackle a 4-variable system with 4 equations with 4 variables in still less than a minute. All right, that's how fast it takes to solve using this method. All right, so now with many of my other videos, I went into great detail so that the students would understand why they're doing what they're doing. That's not the case with this video. That would make this video far too long, and my wife told me keep your videos short or no one's going to listen to the whole doggone thing. And so maybe for those the teachers have already mentioned this, let me just review a few things, and if you haven't had matrices, then it doesn't matter. I'll show you what you need to know ultimately to use this method. Those who've taken systems of equations and written them in matrix form, then you recall it would look like this. where matrix A is what we call the coefficient matrix, and it's comprised of the coefficients of the variables. The first row, 2 and negative 3, those are the coefficients of x and y in the first equation. See, there's the 2, and there's the negative 3. The second row, 7 and negative 1, those are the coefficients of x and y in the second equation. That's why we call this first matrix, the matrix A, the coefficient matrix. Matrix B is what we call the constant matrix because we populate this matrix with these two constant terms over here on the right side. Okay, the negative 9 and the 16. All right, so if we want to isolate xy, we'd have to get rid of this. We would multiply both sides by A inverse, the inverse of matrix A. And A inverse times matrix A would give you the identity matrix, and the identity matrix times this would give you just this, xy. And on this side, A inverse times B, and it's the calculator that's going to do this multiplication for us. It'll figure out what the inverse of matrix A is and multiply it by this matrix, matrix B, and the result will be our answer. All right, so for those who know nothing about matrices, here's the bottom line. To use this method, you need to know how to populate your coefficient matrix. Very easy, just these four numbers, the coefficients of x and y, and how to populate your matrix B. There's these two constants, negative 9 and 16. Very easy. And you need to memorize A inverse times B. And know, of course, on the calculator how to define the matrices and how to execute the multiplication, which I'm about to show you. All right, so let's go ahead and jump in on the TI-84 calculator, and let's first define matrix A, and then we'll define matrix B, and then we'll show you how to make your calculator multiply these two together. All right, so let's, we notice that the word matrix appears right above this x inverse button. And so to access this, we'll have to first hit the second button and then matrix. We desire to edit matrix A. So we have to highlight edit. Either hit your right arrow key, that's right here, twice, or you could have hit your left arrow key once, either way, to highlight edit. Which matrix are we going to edit? Matrix A, which is number 1. So let's hit number 1. It wants to know the dimensions. It's a this is a two rows and 2 columns. So it's a 2 by 2 matrix. So hit 2, enter, 2, enter. And now you can see that we have a matrix with default values of 0 in these 4 positions. And then we need to type in the correct values, which would be the first row, you recall, was 2, negative 3. So 2, enter, negative 3, enter. And right away it pops down here to the second row, which would be the 7 and negative 1. 7, negative 1. And we're done defining matrix A. Now we need to define matrix B. So we'll go ahead and hit second matrix again and highlight edit with the right arrow key 2 times. This time choose number 2. All right, matrix B had 2 rows and 1 column, so it's a 2 by 1. So 2, enter, 1, enter, and the 2 values were negative 9 and 16. Negative 9, enter, 16, enter. We're done defining our 2 matrices, and let's hit second quit to get back to the home screen. And now we want the names of these matrices to appear here. We want A inverse times B, and then we'll hit enter, and that will give us the answer. All right, to get the name of matrix A, we would again hit second matrix, and this time names is already highlighted, so all I need to do is hit number 1, and the name of matrix A appears on my screen. Now I want this to be matrix A inverse, and so I hit the inverse button. Here's your inverse button over here, right above the x squared key. Hit that once. So now we have A inverse times, now we want the name of matrix B. So we hit second matrix. This time we choose number 2. And there it is. That's the expression which, when evaluated, will yield our solution. All right, let's hit the enter key. And it claims that 3,5 is the solution. All right, so back here on our, let's write that down. We got a 3 for x and a 5 for y. See, whatever this top number is here, that's your x value, and then the calculator showed 5 as your bottom number, see, and that would be your y value. Now it's also permissible to let the students express their answer as an ordered pair. Okay, so if they just write parentheses 3, 5, that would also be an appropriate way to write your answer. Or you could write x equal 3 and y equal 5, either one. And that's it. Okay, A inverse times B every time. All right, now let's move on to example number 2, a 3-variable system, which here's where we actually gain the benefit. The 2-variable system could have easily been solved with any of those 4 other methods we had, and we didn't need a 5th method, but with a 3-variable system, it's a different story. All right, here's our 3 equations with 3 variables, and we desire to solve that system. All of these together comprise one system, a system of 3 equations, and the solution would be this time an ordered triplet: a value for x, a value for y, and a value for z that make all 3 equations true. All right, now with this method, this particular matrix method, not Cramer's rule uses matrices as well, okay, but we're not using Cramer's rule here. We're using the method that we used on the first scrub 2-variable system. All right, so let me ask you this. What do you think would be the coefficient matrix? Are you thinking 6, 1, 1, 1, negative 4, 2, and negative 2, 5, negative 1? Good job. That's right. It's just the coefficients of x, y, and z. Now, I trust that if the teacher decides to change the order of some of these, you know, they put negative 2x minus z plus 5y, that you would be wise enough to get everything in the same order so that your x's come first, then y's, then z's, and your constant terms are over here. All right, before you begin to determine your coefficient matrix, you need to have your equations set up like this. All right, what would be your constant matrix? Were you thinking 21, negative 7? Of course you were. All right, good job. All right, maybe that's the hard part of what you need to know. All right, let me make that all visible there. Okay, matrix A, the coefficients. Matrix B, just these constants on the right. And we have to define those on the calculator and take A inverse times B, and that will produce our answer. These 3 numbers will be the values of x, y, and then z. All right, so let's go back to the calculator and hit second matrix and highlight edit. Now perhaps you want to pause the video and finish this on your own. Even though we haven't done a 3-variable system yet, see if you can transfer the knowledge from a 2-variable system to a 3 without seeing me do it. And then just restart the video and we'll see if you're right. All right, let's go ahead. Now that you've restarted the video, here's what we should be doing. We want to edit matrix A, so we'll hit number 1. The dimensions of matrix A, the coefficient matrix, is a 3 by 3. So 3, enter, 3, enter. And then we need to type in the values for the coefficient matrix. We want to type in 6, enter, 1, enter, 1, enter. That's the first equation. The middle equation, we had a 1 in front of the x, a negative 4 in front of the y, and a 2 in front of the z. And the third equation had a negative 2, a 5, and a negative 1. We're done defining matrix A. Let's go on to define matrix B. Second matrix. Edit. Number 2. Dimensions of the constant matrix. 3 by 1. 3 rows, 1 column. 3, enter, 1, enter. And the values of the constant matrix were 21, 14, and negative 7. There we go. And let's hit second quit to get back to the home screen. And now we want to type A inverse times B. Actually, the last operation I did on this calculator was A inverse times B. So I could just hit second enter to bring back the last expression that was evaluated. And when I hit enter this time, it will evaluate using the new values for matrix A and matrix B. So let's go ahead and hit enter. And the solution we get is 218. 218. So let's go back here. And let me copy those down. We got a 2 and a 1 and an 8, and we'll interpret that as 2 being the value for x, 1 being the value for y, and 8 being the value for z. And you could, of course, write that as an ordered triplet. 2, 1, 8, and that also would be fine. Did you get that right? If you did, good. All right. If you didn't, try it again. Find out what went wrong. It's probably just entering one of the values of your constant matrix incorrectly. But that's, you can see how simple that was. Now, suppose the teacher made this worth 20 points on a test. Then maybe you want to check your answer. Would you know how to check your answer? Do you know what a solution to a system of equations is? If you do, you know how to check your answer. A solution to a system is a value for the variables, a value for x, a value for y, and a value for z that make all 3 equations true. So just start plugging them in. It takes, 6 times 2, 12. Add 1, 13. 13 plus 8, 21. 21 equals 21 is true? Yes, these values made the first equation true. Do the same thing with the second equation, the third equation. And after another, 10, 20 seconds, you will know for sure that your answer is correct. And you could turn your paper in with authority, with confidence, knowing that that must be the solution to that 3-variable system. All right, so that concludes our instructional video on how to use matrices. This is one matrix method for solving systems of equations. I hope you understood that and found that beneficial. Remember that this is just lesson 5 in a series of instructional videos that I'm doing on the TI-84 calculator. So there's 4 before this, and then there's going to be more after this, and all of these are going to be available from my website. And my website is amysflashcards.com, and there you'll find all the videos that I have so far, and be able to access and view them there. And you'll also find many other flashcard type drills. If you want, you're interested in mathematics, I've got a lot of mental math drills, how to do math problems without a calculator, without pencil or paper. Both basic, very simple, and very, very complex with many tricks. I think you'll enjoy those. And I would appreciate hearing from you, your comments on this and maybe suggestions for future videos. So feel free to email me at info@amysflashcards.com. I look forward to hearing from you, and thank you for joining me today.